Hey, it's an honor meeting you, Tim. I'm Robert Scoble. So it's a
What is
real
this, Jim's Kitchen?
Yeah, this is on the ranch. Yeah, we got
Yeah.
Buffalo behind us and Seattle Computer Product computers in front of us.
Yeah, we have one of the original Seattle Computer Works machines that you built over there. You know, you don't give a lot of interviews, so it's a real honor to be able to talk with you about the early days of computing. And I like to go back to first principles and understand where it all came from, because we're heading into a new age of robots and autonomous car, well, robots and holodecks, I call them, which you're building. Right?
Yeah, the Paranet.
Yeah, Paranet. Orchestrating all the machines and getting them all to talk about to get together. You know, can you built the original operating system that Microsoft used to build its business. Can you tell us a little bit about those days back in the late 70s?
Well, no, it was written in 1980. That's kind of a general question. Telling about those days. What more can I? More specifically, can I?
Well, Jim, I think the cool thing would be like, so we've got that 1979 board of the 8086, and then the transition from when you went from building the board and kind of trying to get CPM to the point where you did QDOS. That's probably the fun part.
Yeah.
Maybe not fun for you, but it was fun to talk about.
That a lot of trauma in your life.
Well, okay, I can go through the steps of the creation of DOS. So Jim, you came on board what, in like 82? So
No,
you were after
81.
81. Yeah. Okay. So
Tim, I remember when you did the interview with me, the reason you hired me is because I had CPM on my Apple IIe with the soft card. You go, you're a CPM guy, come join us. That's how it happened.
So when just after I started at Seattle Computer in 78, just after I graduated from UW in computer science. And when I first started, I was actually a contractor. I was being paid something like, I think it was $50 a day to redesign their memory. But that changed like in weeks or something. I was like, no, we like you, we want you here. And so the reason I'm going back this far is because when I say right after I graduated, I mean, June of 78, like immediately after graduation. And like at the end of June, I think it was in 78, or maybe it was July, Intel had this seminar on their brand new 8086 processor. And Rod, the owner of Seattle Computer, said, hey, why don't you go check it out? And so I went to the conference, spent a day there, thought it was great, and he says, well, let's go ahead and design a CPU, a CPU card for this $100. So that right there, within a month of getting started at Seattle Computer, all of a sudden we were going from just a memory builder, S100 of S100 memory boards to now we're going to just try to dive into the 16-bit computer, make something that nobody else had yet. And so I worked on that design, and Pat was a year behind me at the UW. Pat Opelka was an engineer that I'd worked, well, he worked for me at the retail computer store. That's where I was. That's how I met Rod Brock, was my work at the retail computer store, in which I was a technician, and I complained to him. It's like, oh, your memories aren't as good as some other ones. And so that's why I ended up getting hired to fix them. Well, Pat Opelka, we hired him there too. And then when he graduated a year later, it's like he was a great engineer. I brought him on to Seattle Computer. So he started working there in 79. So in the meantime, I've got this design going, and we have this first prototype that we got working. I think it was in May of 78. There was some crazy problems with the board. The guy who did the layout had made some mistakes. We had he got mixed up on the inputs and outputs of one chip. And so we had these wire wrap sockets with the leads, the big long leads bent around so they interchanged in pairs and stuck into 4 different sockets on the chip, so that when the little chip went into that socket, the wires got interchanged when they went down into the board. But we got it all working, and then contacted Microsoft. Well, 2 guys to contact: Digital Research about getting an operating system. So there's going to be a CPM86, right? And Microsoft about can we get some programming languages for it. Well, Digital Research was like, oh yeah, we're going to have that by the end of 79. So here it is, mid 78, and they're going to have the CPM by end of 79. I don't know if that was right when I heard that, but that was when we did contact, and that was the story. Microsoft was more interested because they were actively working. They had a version of BASIC to run on the 8086. And so they said, hey, can we try it out in our hardware? So in May, I brought this big Krememco Z2 box. It was this huge box that we, with the 8086 card in it. And I worked with Bob O'Rear on getting BASIC up. And it didn't quite work. But it showed good signs. And then finally figured out what he was doing wrong. And boom, we had it all running. And they were kind of excited about it, and they invited me to go to the National Computer Conference in 1979 and take a spot in the booth they were in, which wasn't actually their booth, but that we were there showing the first computer running Microsoft standalone 8086 BASIC. Well, so we're going along. We actually that was 70. Maybe, yeah, okay. So that's 79, and that May of 79 is when we got it going. June of 79 was when we were showing it. By the end of 79, we were actually shipping it, and we had Microsoft standalone BASIC as its only software with it.
Jim, how were you getting BASIC running there without the operating system at the time?
So that's standalone BASIC is. I mean, that's what Microsoft had started with in the very beginning. It's got a disk, a disk operating system built in, and that by the way is FAT8. So if you want to know where the FAT file system came from, it came from standalone disk BASIC, where their version of it was, when I did DOS, I did FAT12. Well, they had FAT8 in for their disk BASIC. So if you know what those numbers mean, the FAT8, FAT16, FAT32, the number is the length of the number of bits that are used to number the blocks on the disk, and so it directly affects how much you can store. So I started with FAT12, and then they went, then they expanded to FAT16, and then by the time when they hit FAT32, they were able to do 2 terabytes. Anyway, so we were actually shipping this 16-bit CPU in very small quantities with BASIC, and it's that time that Digital Research is supposed to be having their operating system. The end of 79 was coming, and it's like I don't remember exactly what our interaction with them, if I was asking or it was just like, well, they're not doing anything. So in April of 1980, it's like, well, there's no operating system yet from Digital Research, so I could whip up something myself. So that's what I set out to do, and so April, May, June, July. So I always pegged it as 4 months working about half time to get that very first version running, and so it's like 86 DOS 0.11, I think it was what we called it, shipped in like August of 1980, and that was what got us so that we finally had an operating system. Of course, we didn't have any applications that ran that yet. Okay, I'm going to take a breath and say,
Yeah.
how's this story going for you so far? Is this what you want to hear?
It's awesome because you're telling us how the beginnings of the personal computing age really came about. You know, there was a whole bunch of people like you who were building personal computers. You know, Apple had the Apple II, and there was a whole industry of people who were trying to build their own personal
Commodore,
computers.
Sinclair.
Yeah. And then IBM comes in the market, right? And IBM came, I heard the story that IBM came to Bill Gates and said, hey, we need an operating system for this new personal computer that IBM's trying to build. Because they saw what was happening at your retail store and other places. People were buying Apple IIs, and a new market was evolving. I mean, I built Apple II motherboards when I was 13 because they ran out of factory space. They couldn't make enough of them. They were selling so many, right? And IBM in about 1980 came to Bill Gates and said, hey, we're building this personal computer. We need an operating system. And Bill sent him down to Gary Kildall at DRI Research because he had CPM. Now, I heard the story.
So that's pretty much right, except you want to say that they came to Microsoft saying, we're building this computer, and, you know, and Microsoft's, you know, not that, and it's not that we want an operating system from you, it's that, you know, we need software. And Microsoft's like, yes, we have, you know, we have all these programming languages we'll put on it, but for the operating system, yes, for the operating systems, go to Digital Research. They're the guys.
Yeah, and back then CPM, how much did CPM cost to buy back then? Because I know my dad bought a memory card, a CPM card that cost like $2,000.
Soft card.
The soft card.
Yeah.
And then CPM itself costs like $3,000. I heard from.
No, it would have been. I don't remember what it was, but it would have been. You know, I don't remember if it was. Well, I don't remember, but it wouldn't have been more than like $100 or $200 at most.
Really? Okay, because I heard it was real expensive back in the late 70s. But anyways, IBM went down to Gary Kildall, and Gary couldn't make a deal happen with them because they wanted to pay $25 for their operating system, right? And then IBM went back to Bill, and Bill found you. And
well, so
at least that's what I've heard. I wanted to hear it from your point of view because you built it and you sold it.
So I don't know exactly what happened with IBM visiting Digital Research. You know, so through a few, you know, a third or fourth hand story, it was, you know, Kildall was not there at the first meeting, and they, IBM complained to Microsoft guys that we cannot work with those guys. They're well, first of all, like as I understand, the first meeting accomplished nothing because of they were just butting heads on non-disclosure agreements. It's like they couldn't even get past that.
Yeah.
You know, IBM goes into Microsoft and says, "Here, we're doing this project. We can't tell anybody. Here's the non-disclosure agreements," and they just go, "Sure, sign. You know, we're on board. No sweat." And Digital Research going, no, well, you know, as I understand it. So,
yeah. I heard it from
nothing happened. You know, they get hit by that, and then they just can't make. You know, it's just like they just complain. We cannot work with these guys. That's what I remember hearing from, like, you know, Gates saying or somebody down the line. And you know, obviously they know all about us. We've you know, I mean, I've been up there working with their guys, and you know, and after that, you know, after writing DOS, it was on the phone, hey, you know, I've got this operating system. Can you adapt your languages? You know, it's just, you know, to that. And, you know, the response to that had been, oh yeah, you know, we'll do any kind of custom work for a price, right? You know, it wasn't like, you know, oh, that's gonna be an operating system we want to support. It was just like, you know, you pay us, we'll do it. And so now it's like, oh, well, you know, we know they've got this, you know, Microsoft people, we know they've got this thing, so let's, you know, I guess we can go pitch that to IBM. And so we heard at Seattle Computer, we heard, oh, from Microsoft, they have a customer that it's going to want DOS, and you know, work out some kind of deal, and you know, so, you know, IBM apparently was just glad to get digital research done and move on. And whether or not I don't know that IBM knew anything about us before Microsoft pitched us, but after they pitched us, we did at one point, as I understand. So, I didn't know what to make of it at the time, but the owner got a call from IBM about the operating system, and he went, I got an interesting call, and then we never heard from him again. We didn't know what it meant, and at the same time, we're dealing with this mystery customer that Microsoft has. And it's like, could it be, well, we don't know. So, and so the deal was, Seattle Computer got, what was it? I've told it so many times, but now I've forgotten the specifics. It was something like, a $10,000 just fee to just sell the operating system for Microsoft, and then $15,000 per flat fee customers. So flat fee deals were still being done at the time, and that's that was kind of arrangement that they were getting. So it was like, I guess it was like a total of 25 grand that they were paying Seattle Computer to be able to distribute it unlimited quantity on the IBM PC.
So Tim, but there was a split on the BIOS stuff. So who made that decision on splitting out the BIOS so you could continue owning the license there?
Those sound like two different subjects.
Well, the DOS, the OS, and the BIOS, right? Because
Well, I mean, you always have a hardware layer. HAL in Windows NT or whatever it is. BIOS, you have something that interfaces to hardware, and DOS was no different. So there is an interface layer. The deal we're talking about now that was done originally. So so it includes the cash payment, includes this list of stuff that IBM wants. There's like 13 checklist items that we had to add, and so it's done for this flat fee. And then in July, I think, so this is 1981 now, so Microsoft is just before, so turns out to be 1 month before the PC is announced. So, and by the way, okay, yeah, and an important, so it's somewhere in there, let me think about this. So I had worked, let's see, get it all straight. In 81, like, so I wrote DOS in 1980. We did this deal with Microsoft for IBM right at the end of 1980, and I'm working on it through 81. And then there's some little butt heading between me and Rod, and I call up Microsoft and say, oh, you got something for me up there instead. And so I end up in what was that, June, or I guess May, or maybe it was May of 1981, switching from working for Seattle Computer to working for Microsoft. So my first day there at Microsoft, I get to see, the customer is IBM, and brought to the back room, and I become, it turns out that Bob O'Rear, the guy that I'd worked with on BASIC, he was the guy working on that abstraction layer, the interface between DOS and the IBM hardware. So they'd take the disk we sent, which had interfaces to Seattle Computer hardware, and they'd throw that out and put in their layer. So then I started working with him on getting that all ironed out, and so I'm at Microsoft then, when in July, Microsoft has a meeting with Seattle Computer about taking, just buying DOS, instead of this, whatever it was, 15 grand per customer. We want to own it, we'll pay you for it. You get to keep using it. So you get money, you get to use it forever for no royalty. And but Seattle Computer's not a software company. They're not going to, they have no means to market it. So so that deal, so before, as that deal was being finalized, I got called in as a Microsoft employee that still helped out Seattle Computer. I got called into the meeting, just, it's like, hey, Rod wants to hear what you think about this kind of thing. It's like, oh, sounds good to me. So it's sort of I got to bless the Seattle Computer Microsoft deal that transferred the ownership of DOS to Microsoft. So that happened. That happened in July, just weeks or a month before IBM announced. So at the time, Seattle Computer did not know who the customer was. I knew, and I didn't know that. I had no idea that IBM would be, that IBM's presence in the market would be this huge, explosion of interest. It's like, the computer was not that impressive. It was like half as fast as Seattle Computers, or so. So.
It's 88. That's the problem, right? It's 888. But they had the socket for the 887 there, right, Tim, on the first board?
I didn't hear what did you say first?
Well, it was inferior because it was an 888 8-bit bus versus the 16.
Right, it was that, and plus it had this bizarre 4.77 clock speed.
Yeah.
Well, we were running 8.
Yeah.
And so the clock speed was nearly half. Plus, it was only doing 8 bits at times in a 16. And so we had more than double the speed on it. Anyway,
which is a pattern, the best thing doesn't always win. I sold beta VCRs and VHS VCRs, and the beta was higher resolution, right? And most of the engineers in Silicon Valley would buy it from the VHS because there was more context. It's hard to figure out what's going to be the path to market success in these areas where you're a real pioneer in building a new product.
Well, Tim, so I came in right after I graduated, in May. And, we were kind of looking at this thing and going, well, ours is way better, right? So we thought like, hey, well, that's great. IBM, go knock yourself out, but ours is faster. You've got 87 in there. You're getting those early chips from the 87. You hooked all that up. And then what we were doing is we're just kind of running speed tests on all those languages. Remember, we had that rack of all the languages, Tim, like Pascal and Fortran and COBOL and stuff. We're testing and doing benchmarks, but then 1, 2, 3 comes out. Well, okay. Everybody starts.
So I mentioned while I was at Microsoft, I mentioned I was still doing things with Seattle Computer. So I designed their first their first IBM plug-in card, and that's what really sent their profits soaring. Is there was one of the guys at Microsoft said, there was only 5 slots and there were so many things missing that, gee, you really got to put at least 2 things on one board. It should have memory and a serial port. So, well, that's a good idea. And so Seattle Computer had the first multifunction card where you got serial port and memory on the same card. So that would have been just after they announced we got going into that space. That guy who said that was Bob Wallace, who I worked with at the retail computer store and then became like the 5th Microsoft employee.
What was the challenge of building an operating system back then for you? What was the hardest thing that you had to figure out how to do?
I spent a while just studying ways to track what disk space, how files are where the space, let's see. In college, we had a class that talked about, here's the way Unix cracks where it puts the data for a file. And and we had at Seattle Computer, we'd used UCSD Pascal. Right? That was one of the few things that was out there at the time. It was supposed to be portable, and it had this horrible crimp where it allocated its space sequentially. So if a file wanted to grow, it had to copy it somewhere else. And so I was looking. I knew how CPM did it with it had these 1K blocks and it had a list of 16 of them. We're getting down into the innards of how this happens, and I just liked what I saw in the Microsoft standalone basic FAT8, except that it was just it was absolutely committed to a disk no bigger than the than a floppy disk.
Yeah.
And, so I just expanded it by 50%. And it's like, wow, with this, you could do a disk as big as 64 megabytes, which I'm sure is the biggest anybody would ever need.
And now we're in a petabyte world, right?
Yeah.
Oh man, what would you like to correct from people's stories or understanding of that early age of computing? I have my kids sitting here with me. They have no idea what you guys were doing back then. They didn't exist. They learned how to read on YouTube, right? So it's a different world now. Anything that you'd like to correct? For instance, I heard that Gary was really mad at you because he said you copied him or something like that. Could you take that on or correct that?
Yeah, I mean that's absolutely true. And when would this have been? The kind of the mid to later 80s. He actually like looked me up and called me to bitch at me about having. He called it ripped off. The words he used, you ripped off CPM, and and there's this whole camp that believes that thinks that it's somehow this is completely illegitimate. What I did in designing DOS, Intel, so they've got the world had started out with the Altair. That was their 8-bit processor in the Altair. So now we're using their 16-bit processor, and they had come up with a translation process that you could take a program written for the 8-bit and their 8-bit machine, and there was this process that would translate it into one that would work on their 16-bit machine. So it was translated at the source code. You couldn't take a program you bought and do it. This is something that if you owned it, you had the source code for it. It would translate the source code into a 16-bit program. Okay, so I said, well, that's a nifty idea for getting things running quickly. I had a number of tools, for instance, myself that I'd written for the 8-bit version, and so I'm going, well, so if I translate those, if I use this translation process, then the way it asks CPM how to do something, the way it says, okay, store this on disk or whatever it is, there's a certain sequence of events that get translated to the 16-bit world. So I'm going to make at least one interface to DOS except that translated interface. And so in that sense, I was imitating the CPM interface. I was, every function number in this, what they call the file control block and all this stuff, that was all, from just lifted from their documentation. It's like CPM says, this is how those things work. And so it's like, well, when you translate that through the process, you put the function number in the C register in CPM. Well, that means it goes in the CL register on the 8086. There was a specific set of rules. And so, did all the same functions with all the same, associated things that went with it. Of course, underneath, CPM had this clunky way of storing things on disk, and FAT was much better. It was completely different. So there was no similarity in the code underneath. It was just this top level that said, here's how you ask for service. It's like, okay, you can do it the same way. So that choice of mine to say, okay, I'm gonna be, so I call that translation compatibility. I applied it to my own tools. I had an 8086 assembler, the translator tool itself. I had a tool that translated the 8-bit to the 16-bit. I had like a handful of 5 tools, and they just pumped them all through the translation, and boom, they were all running on DOS, instantly. So it worked, but I don't think anybody else in the whole world ever used it. And so there turned out to be no value whatsoever in having done that. I had viewed it as, here's a way for people to, these software developers to get up and running quickly, but it's like, nobody did it. And so I bought this grief about, you've copied CPM. Well, it's called implementing an interface. and we all do it, and it's all okay. It's not a copyright violation. There's no code, there's no 8-bit CPM code in 16-bit DOS. It just implements an interface. So it's like, okay, we're going to publish a manual and explain the interface. This is digital research, and all you guys that want to implement the request side, that's great. But if you want to implement the service side, oh no, that's illegal. But our interface is a one-way interface. It's like, well, it doesn't really work that way. You publish it. It's like we could do it either way. There was, what was his name? Harold Evans wrote a book about how. He has this book about all these great inventions, and CPM was one of them, and this guy Tim Paterson, or not, CPM and DOS, and DOS is just a ripoff of CPM, so it was really a Gary Kildall program, and I sued him about about that, but I was ruled to be because I had was known somewhat in the industry. The judge ruled that I was a limited public person, and that people could say anything they wanted about me.
Welcome to being a public person. I have a similar problem. Anybody can say anything about me. Well, man.
And so, of course, the digital research camp. Well, that's a victory. It's been ruled that he really copied you. That was their take on that.
Interesting. When as the computing industry evolved into GUIs, with Windows 3.1, Windows and Windows 3.1, Windows 95, DOS was still running everything underneath, wasn't it?
Through Windows 95, it was, yeah. I remember, like, I was at Bob O'Rear's retirement party in like the 90s, and some guy came up to me and said, "Oh, I love the way you wrote the time of day clock code." That was, it's still there in Windows now. It had something to do with the way IBM had this weird clock system where it's like, he said, well, this thing is ticking and it's almost, I don't know, overrolling once a day, and they thought almost was good enough. No, you've got to have it right, So I had this calculation that like adjusted their ticks so that it's like, yeah, we're going to get actually the exact right number of counts per day. Anyway, so there was some clever, it's all assembly, every bit of this is assembly language, by the way, DOS and all, this BIOS stuff and everything was all assembly language. And, so they were, it's like, oh, this one guy was like, oh yeah, that was the coolest code, he thought. So yeah, it was still alive and kicking through Windows 95, which I guess Windows 95 we got, whatever Windows
98 Me, right?
Yeah, Windows Me.
Well, Vista was based on the NT, so Windows NT was a different kind of operating system that wasn't built on top of DOS, right?
Right.
Or am I?
So that's Windows NT, Windows 2000. That's a whole new.
That was Mark. That was yeah. Letwin did that one, right, Tim?
Yeah, Dave Cutler and all that team. The question is, if Windows 95 never was a complete rewrite of an operating system from the scratch, right? And Bill Gates didn't believe in rewriting that way. He always wanted everything old to be able to run on the current operating system. Did he make the right choice there? Obviously, he's rich because he made the right choice. But would you have made different choices along the way after DOS if you had to do them today?
I think they handled things pretty well. So right away after I left, so I did DOS 1 and 1.25, or IBM's 1.1. Well, that I was at Microsoft a year, then I went back to Seattle Computer. Now that they're thriving, selling the IBM plugin cards that I designed while I was working for Microsoft, I went back to Seattle Computer, and so while I was at Microsoft, you know, I was the DOS guy, and then this guy, Aaron Reynolds, was hired like fresh out of school, I believe, maybe with a master's, and he was put under me, and then Mark Zvikowski, who I'd worked with on the linker. I understand that he and Aaron are the guys that took over DOS, and they really dove into, you know, they added the big deal, of course, adding, you know, hierarchical folders, right, instead of just having one top level directory, you know. So they went right after it. They made huge improvements, you know, just changing the, you know, providing this whole new interface, you know, where, you know, there was file handles instead of data in the user's space, you know, just really cleaning it up, making it much more Unix-like. So, you know, they really did, they really handled it well. And, you know, it made, you know, obviously there was things built, you know, Windows was built on DOS. And so, so, of course, that's just going to keep getting bigger and bigger. And then, you know, you got the parallel projects of, you know, what they called a portable Windows, which I didn't even know what they meant by that then. I thought portable Windows meant for portable machines. And then I finally figured out that it meant it could be ported from, you know, to different CPUs. It was all in C, so that you just compile it for whatever machine, you know, whatever machine you want. I mean, I think the evolution of all that made a lot of sense. They might have made, you know, Windows 95 maybe should have been the last, you know, because NT was going by then. But you know, so Windows 95 is strictly this cover over DOS. Yeah, for sure. But that's, you know, that's the way Windows had been designed through that point. So, you know, and then Windows NT finally caught up and did everything. So, you know, it became time to switch. So I think they did it was a really appropriate evolution.
Yeah. Any fun stories from the early days that you like to tell us? Going to computer fairs or working with people in the industry in the early days. That, you know, because you started it. I don't hear a lot of these stories from you.
So one, not much of a story, but they had the linker was the Microsoft linker was a really big program, and it turned out that, you know, that they needed an IBM PCs cannot have, are somehow restricted. Well, first of all, it's got ROM in their memory space, so they're unable to have 1 megabyte of memory in real mode. Okay, so, you know, these machines, you know, when they got the 286 and 386, they had, you know, 886 originally had a 1 megabyte address space, and then the 286 and 386, you know, there's the original 1 megabyte real address space, and then there's the virtual address space. So the 386 could have all kinds of memory outside that. Well, the linker was only ran in real mode, and so for the linker to link itself, it needed a 1 megabyte machine, and Seattle Computer was the only guys that made a 1 megabyte machine. So that you could put 16 64K memory boards in a Seattle Computer case, and that was required. So that machine lived for years and years past when it really should have. It's, you know, it took them a long time to get the linker to actually run like in 32-bit mode, so that it, you know, so it didn't have any memory restrictions. So there was this Seattle Computer machine sitting on the floor of some guy's office, and like whenever the linker was going to be, you know, updated, it's like, okay, we got to link it on the Seattle Computer machine. It's the only one that can do it. So that lasted. That was amazing how long that machine lasted in its lifetime. Seattle Computer, in order to make that happen, so that every byte was available, its boot ROM would disappear. This boot ROM overlaid RAM for booting up, and then it would disappear and allow the whole, you know, 1 megabyte end to end available to the CPU.
That was a pretty expensive computer at the time, Kim.
What's that?
It was a pretty expensive computer at the time.
Yeah, it would have been.
It was like $900 for every 64K.
For 64K, not a meg, not gigs, not terabytes.
Well then, Tim, you.
Well, when I started at Seattle Computer, the 16K boards were 400.
Yeah.
And so to hear that a 64K was 900, yeah, good deal.
But then, Tim, remember you did so we're selling these $900 memory cards, 64K, and then Tim, you came out with a 256K dynamic RAM board. Remember that?
No, I don't.
So it's four times the memory and the same price.
Okay.
Remember the gold chips?
Yeah. Okay. Sort of vaguely.
Yeah. So then we could get for $4,000, you could have a megabyte.
Yeah. The machine that Microsoft was using was an older one that had all 16, 64K points.
Yeah, that's $16,000 of memory.
Are you shocked at I'm shocked at how fast the computing world has changed in my life. I mean, we throw away computers now. People who use vapes have little computers in them that are more powerful than what you had to work with back then, and they throw them in the trash. That's how much the world has changed. Now in this world of AI, you're talking to the computer. Does this shock you at all, or did you dream about this world even back then?
Well, obviously, I've never been one to accurately predict where the technology is going. If I thought a 64 megabyte drive would be, would last. I just watch it go by. I don't think about it much. It's like, okay, there it is. I accept what's going on. I don't use AI myself. You get stupid wrong answers once. It's like, yeah, I'll just turn off that and do things the way I've been doing it. So in my own work, it's like I've basically I'm building all kinds of little electronic gadgets and stuff like that. So I'm working with stuff that I have 48 megahertz low-end ARM processors, for instance. So it is actually steps above what I was doing, but we're talking small systems which got one microcontroller chip and that's about it. That's the whole. I have this is a digital readout that I make. There are a couple of these installed at the local high school where I mentor on their 50-year-old Bridgeport milling machines. I make that from scratch. I have my own with this custom designed circuit board that's just got an MCU chip and like nothing else. And so I love working, I've got all these little projects around here where, there's a motor controller with, every one of them's got the same little MCU in it. So I'm just like living in this super low end world. Everything's bare metal. I have no operating systems, any of this stuff. My DRO, we flip it on. It's fully operational, like at 1/2 a second. I have a DRO. I started doing that when I bought a mill with a digital readout. You turned it on and it spins. Even that spent 20 seconds or 15 seconds, like rotating a screen while it thought about starting up. And it's like, no, I want it on right away. So I build stuff that if it's like if there's a fault in some of my robot controls, it'll reset and restart, and you won't even have seen the robot glitch. It's just like the robot just keep moving because it'll have restarted so instantly that it's like, yep, we're going in. It relinks to the radio, and it's back online. In like 1/10 of a second. So no, I didn't see anything happen. So I love this bare metal low end. And as part of it, like I've written a math pack for this little processor. I've written a math pack, so it's at least twice as fast as what is what the run times that that come with the software that they give you. So on my GitHub, public domain license, anybody could use it. But it's what so I was writing math for the, I wrote all the 886 math that they ever used. So and it's like, you know, that was kind of my thing. And so now it's like I'm just staying in this world of the low end, you know, assembly language some of the time, and you know, and it's like, okay, yeah, I've got a.
You're not going to go to the Apple Store and put on a Vision Pro and join the weird holodeck world that I talk about.
Well, you know, so I just bought myself
an autonomous car or anything like that.
I just bought myself the Intel 9 285K, which was the most expensive desktop CPU they have, because I've been doing all this CAD, and the CAD program is just like it ground to a halt when I'm building. You know, I have a BattleBot design I'm building. I'm building a robot to compete, and it just like it went over the edge for the CAD program. I'm just, but I built the computer. You know, I buy a motherboard, I buy a CPU chip. You know, I put them in the case together, but you know, that stuff all takes care of itself.
I think we're heading into a new age where people are going to have a choice of, you know, just disappearing in front of a slot machine and being addicted to the entertainment or whatever that you know is presented, or join the builders, join the creators, join people who, you know, come up with new things and build new things. And it's an exciting time to be a builder. I mean, we have 3D printing now that's just amazing, and I see your workshop is full of little things that you can build, right? How do you inspire somebody to try to build things, right?
Well, I don't know. I mean, I don't. So I guess my contribution these days is, you know, I do stuff that everything I do that I think is useful it's on GitHub, public domain. It's unlicensed. So, you know, I don't want to get anything for anybody who needs it to be able to use it. You know, so I've got a number of different little things on there, but you know, but my main thing now is like I'm just volunteering at the local high school for, you know, FIRST Robotics, you know, which we're about actually this Saturday we're kicking off the next season. We're going to build our robot that's going to go compete with other schools, and you know, so it's showing those kids how it goes, and you know, as it turns out, even though my expertise, you know, 20-year career or more in software and computer engineering, the role I end up playing at the school is the mechanical machining advisor. You know, how to run the mills and all this stuff. And the software guys, it's like, no, we're okay. We don't need your help. You know, well, okay. But you know, I'm just trying to, you know, so I've been doing that for 5 years now, and I'm, you know, so I just try to keep the kids excited about what we're doing, and you know, I do the training, you know, how to use the machines, and so that's you know, so it's at a really small scale, you know, just this work at one high school, but you know, when the season gets going, I'll be there 3 days after school a week, and at least 1 day on a weekend, you know, so I end up putting a lot of hours in, and you know, drive the kids to the events and stuff like that.
Yeah.
So that's my thing now, other than what, you know, these bits and pieces that show up on GitHub for you know, my math for this processor and all, you know, these things.
Well, it's been a pleasure talking with you. I could talk to you all day long. You know, I'm not technically enough to get in the weeds with you, which bugs me. I wish I had more skill of being able to talk about assembler with you, or dig into some of the things you were building either back then or even today, right? What would you say to the nerds out there who are building this world today? You know, maybe somebody who's, you know, trying to build a robot company or an AI company.
I don't think I have any special wisdom. You know, let's see. So, my mantra is, I've learned from my mistakes, and I've learned a lot. So, so yesterday and the day before, I was out in my, I'm building this robot. I'm cutting my own gears. I'm out in the shop. I start cutting a bigger new gear, and it's just, all these teeth are great for a while, and then it starts cutting them at the end. It starts cutting them on top of other gears. So it's like, the blank, which is not easy to make, is all ruined, and the big problem is I could not figure out what had gone wrong. So it's like, okay, all I can do is start another one and watch it. So that's what I'm doing. I'm watching this. It's like, and I finally see so I have a computer controlled mill, CNC mill. It's turning this guy and cutting the gears. I finally noticed that the spindle case is bumping up. The gear is so big, the spindle case is up against the gear. And so it's like pushing on it, and it's making it out of whack, and it's turning a little extra. So it's like, okay, well, I've lost another gear blank. But I've learned, at least I finally learned from my mistake. And so now I'm going back like, oh yeah, the gear cutter is a certain height, except that when you have a different actual blade for different sizes. So this is like the biggest blade, the blade for the biggest 4-inch diameter gear, and it's like, well, that may explain why the machine had, the length of this cutter is normally 1.35 inches or something, but it was about a 1/4 inch longer. It's like, oh, that's because there was a 1/4 inch spacer there to make it long enough so it didn't hit the spindle case anymore. Oh, I get it. Too bad I didn't remember that from a year ago, last time I cut the gears. So I just feel like I'm a mistake-making machine. And it's like, but so the intent was to make 8 sets of gears. So I've done 3 sets, I think 3 or 4 sets so far. I've gotten 5 out of each one. The three either, depending on how many, sometimes I started with 7 blanks, some with 8, some with even 9, but I've only been able to get 5 good gears out of each set so far. So anyway, I'm just learning, and I am, so it is one of my things that is I just keep expanding what I'm learning, so I in 2017, I had combat robots before, but I'd never used a milling machine. I'd never, gone, and since then I've learned manual milling, and then I've computer controlled milling, and now I've got a lathe and arbor press, and I've just, now I'm cutting gears, and I'm just building, just to keep expanding the range of stuff that I'm doing. I really enjoy it, and it's going all different directions. I mean, it's in software as well, and so I'm just I have a subject that I enjoy that allows me to just keep learning, and I don't think, like I said, I don't think that the knowledge. Well, what does happen is, it's like I figure something out. It's like, oh, I'm going to write a magazine article about that. so my DRO, there's been a magazine article about it. So, by the way, let's see, looks.
Love that. Yeah, I used to work at Visual Basic Programmers Journal. I think you were working in the Visual Studio team at that time, or back in the 90s. Yeah. So I'd edit your article if you sent it in. Anyways, it's been a real pleasure talking to you. It's rare to be able to hear how a company like Microsoft started, and from an engineer's point of view, a person who's actually building the technology, not the the CEO who's on TV or something like that. Any last things that you want to talk about that at early age?
Well, I guess one general thing is I've seen these things happen that alter courses. And in my case, for instance, what got in college, I met a guy that that we just really got along with. And so immediately the next year became, signed ourselves up as roommates. And he earned a lot of money in summertime. So he was the one that bought the Unzi computer that we used. It was his money that made that happen. And then that made me, knowing, having built one of those, he bought it, but I built it. And, then the ad appears in the retail in the University of Washington Daily about a job at the retail computer store. So that's what gets me at the retail computer stores. I built one of these things. I know how to do it. Okay, so you're hired as a technician. And that gets me then talking to Rod Brock about how his memory boards aren't quite right. And that ends me with a job at Seattle Computer. And so, having met this guy who's, 50 years later, he's still my friend. I still hang out with him at least once a year. It's like, but, him being there and being, so easygoing, it's like, yeah, we can buy that. And that was just, it just changed the course of my life. Had that not happened, I wouldn't have been anywhere near those small computers. And, so given that one, I had that impact then at Microsoft, that I ended up going that route and then writing an operating system. I could have not done that. If I had not been there writing an operating system, things would have come out a lot, a lot different. They may have gotten there eventually, but they weren't operating systems at all and didn't want to be at that time. So that was, that was this event, that it changed their life, their company forever.
Yeah.
And I also mentioned my next door neighbor, when he retired about the same time I did in the late 90s, and his wife says, "Oh, Steve doesn't know what to do with himself. Will you have him work on the robot with you?" And so, yeah, come on, Steve, help me out with this robot. Well, then he actually spent the rest of his life, he passed away some years back, but yeah, he actually spent the rest of his life totally absorbed in robots, putting on events. And it's like, oh, wow, I had that impact on him again. So there are these things that cause, that happen that cause, this total vector off into a new direction that never would have happened, and not just one little thing happened that way.
I totally get that. Vic Indotra called me when I was working at NBC, and he told me the phone call would totally change my life. And he invited me to work at Microsoft, and I did, right? So some of these moments happen in your life, where you're just in the right time, right place at the right time, working on the right thing, doing something interesting, and somebody notices you and changes your life, or things evolve and companies are formed.
So certainly changed mine. I was kind of hacking around on the CPM thing with Apple II, and then Tim hired me. And that changed everything, because I've learned first principles on how operating systems were designed, how to do things fast, and decisions you used to make. So yeah, I always think about that. That's why I have this thing. I go back to it and think this is the roots of all of it.
It's so
one little detail though, I didn't hire you.
Yeah, you did.
You got hired when I wasn't there.
I know, but you came in. You came in to interview me.
Okay, I did. Okay, did I? That was one of my little help Seattle Computer out things while I worked at Microsoft.
Because what happened was, they weren't wondering if this guy's going to be able to handle it. And you came in. I had my Apple IIe and this Z card. I was doing CPM. He goes, "Well, show me what you're doing." So I said, "Look." He goes, "Oh yeah, you're hired." You said, "Yeah, I'm hired."
Craziness, and how an industry is born.
Yeah.
And now we're in a new world of robots, and you're still working on it. That's awesome. Anyways, what else should we talk about? Did we cover enough?
I'm trying to
give people a little insight about how Microsoft Corporation started, how DOS started. I think that was the goal.
I think we covered it.
Yeah.
Yeah.
And so I appreciate it. Where's your GitHub? What you just publish under Tim Paterson, or?
Yeah, I'm hard to find. GitHub.com/Tim Paterson.
One T. One T.
One T.
Yeah.
Great. Love. Thank you so much.
Thanks, Tim.
Okay.
No problem, Tim. Thank you.
All right.
And I'm without it.
Yeah.
So this is Tim's brother's computer. And so Tim's brother passed on. Tim said, hey, look, you know, I know you lost your computer. How about I give you my brother's? So that's how I got this one. So I'm so happy to have this. This is the original. So yeah, we buy an OEM type thing, and
This is very special.
we didn't even paint it. We just bought these things.
Yeah.
And then later I said we stenciled on this thing and we got rid of that.
Who are you?
Me, Jim Harding. I used to work for Tim Paterson at
Tim Paterson.
at Seattle Computer Products.
Tim Paterson started DOS, and Bill Gates bought it from him and started Microsoft. So this is like before Microsoft.
No, Microsoft had already existed.
Okay.
And what was happening was
But he was selling basic product.
he was selling basic. And so if you remember, I think it was Comdex,
Yeah.
1979, Bill Gates came out with basic for Apple II.
Yeah.
And that was kind of their major launch. And so then the Apple II was like the bee's knees.
Yeah.
And they had asked Tim to go build the soft card. So that was a Z80 chip that would fit in the Apple II so you could run CPM and all that kind of thing. So
Which was the big OS of the time.
it was the big OS.
My dad bought a card for our Apple II to run CPM.
Yeah.
The card alone cost $2,000 if I remember.
Yeah,
right.
oh yeah.
And CPM costs $2,000.
Yeah, I was in college, I had an Apple IIe, and I only bought it because I didn't want to work on VAXs and CDCs.
Yeah.
And I remember my professor, I was taking my final exam on an algorithms class or something like that. And his name was Ed Lazowska. He was a young guy, like 26, 27 years old. He went on to become chairman of the computer science department. But anyway, I said, hey, look, Ed, I'm not taking the final. He said, well, you're going to fail. I said, well, you can be in your office in another hour? I said, yeah. So I walk out. He says, you're failed. And I said, nah, not really. So I came back and I plopped my Apple IIe down.
Yeah.
And had my soft card in there, running Z80 and CPM. So up comes Apple II, operating system, Apple DOS, and then CPM comes up, TP/M, and a little blinker, and basically I've got a Pascal interpreter. So it's the UCSD interpreter for Pascal. Wow. So I'm running that. So now I can do all my homework, all my courses, and I was a research assistant as well, and we were all doing Pascal at the time. That was the
hot language.
That was the language at the time, right? So I go back to Ed, I plop my Apple down. He goes, what's this? It's a personal computer. What's a personal computer? Well, it's this Apple II thing here. So then I did my exam while he was in his office, finished it. He said, well, yeah, you get an A, obviously. This is cool. Well then, because of that CPM thing, I met Tim, and he said, what are you doing with the CPM? So I'm doing all my assignments and stuff. He said, well, why don't you come work for us? So then I joined them, and then he's building this thing. He's got the card built, and then he does this thing with.
Was this a retail operation that people could
This,
go into the store?
I was, if we have time,
meet with you guys.
I should show you
the.
the office. It's still down there. It's a 1116 Industry Drive in Tukwila. Well, I grew up and lived there within a mile of that place. And so they located there, so I was happy. And so I joined there. I'd walk or ride my bike down to the office in the early days. And Tim was just building this stuff, and then he went to go work for Microsoft for a while.
Yeah.
I lost my boss at Microsoft. Then he comes back, but he was making sure that Microsoft, had the right DOS and all the versions and the old fat table and all that stuff that he did. Only Tim could actually write it. Tim was like a speed freak. So everything is as fast and tight as possible. Like, he wouldn't use high-level languages. He wouldn't even use the macro assembler. He'd only use ASM.
Assembler.
Yeah, so he didn't like macros. He's just like,
Now AI can write that for you.
of course you can. Yeah.
You're gonna
So he was just a speed
can
freak.
program an Apple II and emulate an Apple II I saw the other day in a large language model, right? It's like
I know. Well, the thing is, like, the reason he was a speed freak back then is because, we have this 8086, right?
Yeah.
And it's got 29,000 transistors on it. That's it, right? That's not a whole lot, but back then it was fantastic, right? So he's got to maximize how this thing uses the S100 bus and memory and so forth.
So in order to make this thing scream, Tim just had to write really tight code. And so if he's known for anything, of all the people who know him, he's like the speed freak. Like there's no extra code. He puts no ops in there to get timing perfect. And he made this thing buzz, man. This is, as far as we're concerned, this is a mainframe, right? We loved it. And then, so what was happening is Microsoft was building all these languages. And Paul was really the guy making them all work on these PDPs in a special room, and they do cross assemblers and translators from PDP to 8080. But when the 8086 came out, well, we didn't have an operating system, so they made translators to the 8086. And then Tim came out with his operating system. Then we would have that language run on our machine. So when they saw BASIC running on this, that was the new game. So that was the thing. So Paul and Bill were all about getting languages going. Bill loved BASIC. We showed BASIC running on this thing, and that was the beginning of it all, right? We weren't great at marketing. You'll see stuff in Byte magazine. You'll see an ad for Seattle Computer Products 86, 86 DOS, I think we used to call it at one point in time. And you would see these ads, and then so that people would call us up. The phone would ring. Hey Jim, you pick it up? Okay, I'll pick it up. What do you need? Okay, well this is super fast. Wow, 886, yeah. And so the Motorola was out there, and Apple had come out with the Lisa, and they had a 68,000.
Yeah.
And Intel had its own.
This is like 83.
Yeah.
Like that?
Well, no,
82?
no, 80, 81.
81.
Yeah. And so Tim chose to go with
that
this.
came out in 84. Right?
Yeah. So Tim chose to go with the Intel system because it was 80 compatible. So he wanted to keep the family going, right? 404, 808, 8080, 8086, yeah, and so on. So when he came out with this, he needed an operating system, and I'll let him tell you all the stories with Gary, because we said, hey, will you CPM? Oh yeah, no problem. Was it ready? Yeah, no problem. Well, it wasn't. So that's where QDOS came from, quick and dirty DOS. Okay, I'll write my own. So Tim just cranks it out.
And so what is this particular?
So in order to get going, he had to go buy an S100 bus. Like, we were a small company, we're not gonna go build our own computer. I mean, back in the day, we're not gonna just go out and build our own computer. So you just buy one of these things from a hobbyist, catalog, and you get this clean slate, and then you build your own boards.
Yeah.
So what's the
You
significance?
did some soldering?
They had yeah. So we had there's four
we
women.
We made the Apple II motherboard in our mom's
Yeah.
kitchen, and she taught me how to solder.
Yeah,
on these
so we had a
things.
table.
And we would put them in our dishwasher to wash them off.
Yeah, we had a table about 12 feet long with 4 to 6 people who were working on it, and they're soldering it. They're pushing chips in and they're soldering, and that was the assembly line. And
You
so
haven't lived, man. You haven't built one of these things.
What's the significance of this one?
What is going on with this?
This
It
one
is
is,
a historic
because it's
machine.
was his brother's. This one's the one that was, I think it's the one that was used to do the first demo. Because if you look at the car, the wire wrap there, that was really, really early. If you make a mistake, and you don't have a lot of budget, you just kind of do a soldering job, like,
Yeah.
right? And so this had something to do with timing and cycles on the bus that we had to fix. So this board is probably used for Bill and Paul to see the first demo of QDOS. Wow. I'll let Tim tell you about that, but yeah.
All right.
So when this came together,
This is the beginning of it
this is
all.
the beginning of all. Yeah. So then they did their deal.
This is the beginning of Microsoft Corporation.
Well, it's the beginning of their
Really.
huge success,
Yeah.
right? It's probably, we probably did the worst deal for our side, and they probably did the best deal on IBM and the OEM market, right? So Bill is just a brilliant marketing guy, A lot of people think it was
His dad was
tech
a
guy.
lawyer, so he had a
Yeah.
little legal advice. like
Yeah.
hey, you can sell DOS to other people
He
if
had-
you write it in the contract, right?
He had support, and whether Bill's a super smart guy, like polyglot, but I think his greatest contribution to that company was figuring out how to do the business model for this. like we didn't have much money.
IBM wanted to only pay $25 for an operating system per machine, right?
I don't know what the deal was, but
I heard that from the DRI research people.
Yeah.
That's why they couldn't make the deal happen, because they were selling CPM for thousands of dollars per seat, right? How much did it cost to buy CPM for this machine if you didn't have Tim Paterson?
I don't know. I don't know.
Yeah,
what the cost was. I
I
know.
remember my dad bought a card for Apple II. It was like $2,000, and it was an expensive.
Yeah, that's the
card.
thing. The software.
$2,000 in 1978.
No, that's the Z. That's the Z, that Z80 chip, right?
Yeah.
The soft card.
And then you had to buy CPM on top of it,
Yes.
which was like another $2,000.
Yeah. So when I was in college, I bought the Apple II. Then I bought the
People think the
software.
Apple Vision Pro is too expensive, man. You got to go back to that day.
And I bought-
this
yeah.
machine probably cost the equivalent of what, $15,000
No.
in today's
Oh yeah.
day.
Well, this thing.
In today's dollars.
We were
right?
selling them for about
Because back then, $2,000 is worth, $10,000,
Between
$15,000 to
$3,000 and $5,000 we were selling these for.
in $78, $9.
Yeah.
Right? So today this would be
Well, you remember when
$15,000.
PC came out, for about 5 years, every year was $5,000 for a fully loaded thing, right? Moore's Law didn't make things cheaper. You just had more things on them, right? Moore's
it
Law.
was hard. It was
yeah.
expensive to be a personal computer
Yeah.
hobbyist back then.
No, and
right?
even like the funny.
That's why my dad was an engineer, right? He had the money to pay for this kind of stuff.
Well, the funny
right?
thing
And there
was-
was people all over the world who were like richer, upper middle class to
Right.
rich people.
Well, we had business people who would spend $5,000 on a fully loaded IBM PC just so they could spend $495 on Lotus 123. That's amazing.
Yeah.
Because we didn't really have, all we had at our disposal when we were doing Silicon Enterprise was selling apps. Well, what were apps? Languages. Paul Allen, we get BASIC, great, got that. Paul, can you give us a COBOL? Got that. Paul, Fortran, got that.
Yeah.
So
Yeah.
we were dependent on Microsoft to give us the language so we could sell these things. In the meantime, they're thinking, oh, this thing's pretty cool. Let's go license that and go sell everything.
Yeah.
And so they were smarter than we were, that kind of thing. Right? We're
But
just,
Bill wanted to sell his developer tools, his languages, and he knew that if this didn't happen,
Yeah.
to sell his languages, he'd have to sell these. Right? That's the beginning of Microsoft Corporation.
yeah.
He figured it out. He sent him away twice, I heard. IBM, right? When IBM came and visited.
That's the
We're gonna
lore.
hear that story.
That's the lore.
Well, I
Tim,
heard it. I
Tim will
heard-
probably know even better.
I heard it from the DRI research
Yeah,
people
yeah.
that they met with IBM twice.
I didn't know that.
Yeah,
I thought it was just once.
I heard it was twice.
Mhm.
And they just couldn't wrap their head around the $25 price that IBM wanted to pay for CPM. And so Bill finally figured out, I gotta, figure this all out to sell BASIC, right? If you don't sell a machine, you can't sell a developer tool on top, right?
he figured it out.
Yeah, he
What
did.
about that? He figured it out. So, yeah. So
Well, it's an honor. Now you're making robots.
we are.
We're gonna see some robots.
We'll talk about that. So yeah. So, anyway, this is just kind of the opener. So you can talk. We'll talk to Tim about that in a couple hours or at noon or so. So you'll get the full.
No, that's cool. That's cool.
Yeah, and it's right to have you talk about it, right? Because you go way back.
Yeah. When I was his age, I was building this.
Yeah.
I wasn't smart enough to build the company, though. I was like, smart enough to solder the board, though.
I'm gonna bring some friends up so we can.
All right.